Why isn't infinity minus infinity equal to 0? Why isn't infinity divided by infinity equal to 1? The most common mistake about infinity in mathematics is to think that infinity is an uncountably large number. Actually, infinity isn't a number. Instead, it represents a concept that refers to something without a limit. Sometimes we make simple approximations like dividing 10 by 3 and rounding the answer to 3.33. These approximations don't change the result much, but we can't do that sort of thing with expressions that contain infinity because mathematical operations involving infinity have unexpected outcomes. Let's look at why infinity over infinity isn't equal to 1. The main problem is we don't know if these infinities are the same. For example, we might say that 9 times 9 times 9 without end is the same as infinity. We can just as easily say that 1 plus 1 plus 1 without end is also infinity. So is 9 times 9 times 9, etc., over 1 plus 1 plus 1, etc., equal to 1? We don't know, because neither operation has an end. Therefore, infinity over infinity is undefined. Similarly, infinity minus infinity is also undefined because we don't know if these infinities are equal. For some calculations, we can think of infinity as a number so big that there's no larger number and it has no end. Although this isn't strictly true, it helps in understanding some mathematical calculations that involve infinity. For instance, if we add a large number that has no end to any other number, the result is again a large number that has no end. So infinity plus a number equals infinity. Similarly, infinity minus a number equals infinity. Infinity divided by a number equals infinity. And infinity times a number equals infinity. Now we can understand more clearly why infinity minus infinity isn't equal to 0. Let's assume infinity minus infinity does equal 0 and see why this assumption is wrong. If we add, for example, 3 to both sides, we end up with this equation. Infinity minus infinity plus 3 equals 3. Since infinity plus 3 equals infinity, we end up with infinity minus infinity equals 3. When we add different numbers to both sides of the equation, the result of infinity minus infinity changes in every calculation. Mathematically, that can't be true. Therefore, infinity minus infinity is undefined. Now let's look at why infinity divided by infinity isn't equal to 1. Again, let's assume that infinity over infinity does equal 1. First of all, infinity plus infinity equals infinity, because if we add together two large numbers with no end, we'll have a large number with no end. So if we write infinity plus infinity instead of the 1 infinity, we'll have infinity plus infinity over infinity equals 1. We can write this equation as infinity over infinity plus infinity over infinity equals 1. If infinity over infinity equals 1, the result will be 2 equals 1, which is obviously wrong. So our starting assumption, infinity divided by infinity equals 1, must be wrong. Therefore, infinity over infinity is undefined. So how do we deal with these kind of equations that contain infinity? The answer is by using the concept of a limit. A limit is the result of approaching a value ever more closely. For example, let's take a look at the function y equals 1 over x and put in some increasingly large values for x. We can see that as x gets bigger and bigger, y gets smaller and smaller. In other words, as x approaches infinity, y approaches 0. We say that the limit of y is 0. Finally, let's take a look at one of the most confusing expressions, 1, to the infinity. 1 to the infinity is undefined. You might think that if we have a function that is 1 to the x, and if we give some numbers to x that gradually increase, all the results will be 1. So 1 to the infinity should equal 1. It should have been 1, but there's a special situation for 1 to the infinity that makes 1 to the infinity undefined. Let's look what it is. Let's say we have two functions, f of x equals 1 plus 1 over x and g of x equals x. If x approaches infinity, f of x equals 1 and g of x equals infinity. So we can use f of x to the g of x to reach 1 to the infinity. F of x to the g of x equals 1 plus 1 over x to the x. So when x approaches infinity, 1 over 1 plus x to the x equals 1. But in mathematics, the limit of 1 plus 1 over x to the x refers to a special number called Euler's number, the value of which is 2.718281, etc. So for 1 to the infinity, we've ended up with two different results, which can't be right. Therefore, 1 to the infinity is undefined.